Welcome to this EDUcast, conferencing done right, sponsored by Yamaha and Telecom Reseller. With me today is Holger Stoltz, Senior Director of Technical Sales and Marketing at Yamaha, and I'm Gary Auden. And as we always do, we discuss our agenda before we start. We're going to be talking about conferencing from a technological viewpoint, not conferencing just sort of I make a connection and we can collaborate, because conferencing does have a lot of issues in making the technology work. So we're going to talk about sound processing features, and we have 8 of them here that we're going to go through individually so you understand what's happening when you have a conference call going and what may have to occur to compensate for the problems that we encounter in the rooms. So let's start off, Holger. Let's talk about the conferencing impairments we're going to have to deal with.
Okay. Good morning, Gary, by the way. The different things which we're seeing in conference rooms really have to do with, do I have noise in the room? How is actually the voice being recorded that's being coming, or what's being spoken in the room? And then vice versa also, what's being played back through the speaker? How does that actually sound in the room? It's an interesting way to look at it. Is like an anechoic chamber, for example, would be perfect for the far end. If I'm talking here, you would exactly get, or the microphone would exactly get what I'm saying and send the cleanest signal to the far end. However, for me being in the room, that would be a terrible experience. If you ever been in an anechoic chamber, it feels like naked or cold because you don't get any echo back. So there are actually things which you like to get in a room, which on the other side are for your personal being and feeling good, which are on the other side bad for a conferencing experience. So what we will be talking about today is actually how we get some of these problems resolved using technology so that actually you have a nice room which feels good and also has a good conferencing experience for both sides of the room.
Am I correct in interpreting what you said is that when a room feels sterile, people are uncomfortable, as where when there's comfortable sounds in the room, people just go ahead and talk?
That's part of it, correct. And also part of it is if you are in a room which feels actually nice for you, you might have a lot of reverberation. You might have a lot of echo in the room, which then actually, so while it feels nice for you in the room, it feels terrible for the person on the far end.
So let's move on. What are the technological goals we have then for improving this operation?
It's you have to look at all of the components for the audio in that room. Meaning, you start with a microphone. What can I do with the pickup of the audio? How can I actually change that audio flow which comes in and the form of the audio wave to really make it sound better to the far end? I can change the speaker behavior. So how should sound or audio sound in the room where I'm in? How can I actually improve that sound? And then, of course, all of this getting automatically together. And that's really what the complete signal processing technology does in conference phones or in conference installations for you.
This slide has 8 features on it. 6 of them are, you say, sound processing features, plus 2 more. Would you briefly go through those, and then we'll go back into each one in detail?
Yeah, it's, I think, quickly going over the slide because we will discuss all of them. There are a lot of different ways of looking at how to improve the audio, whether that is what I send over, which has to do with echo cancellation or noise reduction. So how do I make the sound or the audio sound better on the far end? Then how do I actually make it sound better in the room? So how do I equalize the room and make sure that the audio which is played back actually feels good for people in the room? And all of these features, whether they are, as I said, echo cancellation, noise reduction, gain control, and so on, are actually controlled by the brain of the conferencing device, which is the signal processing.
So let's start with the adaptive echo cancellation. I know there are echoes in a room, especially if there's glass walls and the like. What causes the echoes, and how does this work?
So the whole idea of the echo canceller is has less to do with echo in the room, but with I have a speaker where I hear the far end, and that audio comes out of the speaker, and because I have a microphone in the room, that microphone is picking up the same audio. And if I don't do anything to it, the microphone would now actually send the audio back to the far end. So the person on the far end who was just speaking, who I heard on my speakers in the room, would hear himself back. So the idea of echo cancellation is actually to remove what came out of the speaker when it goes into the microphone, so that I'm not sending the same audio back to the far end, which he just sent to me by speaking. Echo cancellation itself, that sounds easy, right? So it's like it's one speaker, one microphone, so I just have to do one thing. Now, in a room, there's a lot of things which come in addition, because if I have glass walls, as you just said, or I have a lot of whiteboards, it's actually what comes out of the speaker isn't hitting the microphone once. It is hitting the microphone in the direct path. It's hitting the microphone being reflected from the glass, being reflected from the whiteboard. So actually the audio, which somebody said at the far end, isn't hitting the microphone once. It's hitting the microphone multiple times. And what an echo canceller really has to do is to look for all of these instances of what the speaker or what just came out from the speaker, all of these instances, and has to remove that from the audio that's being picked up by the microphone, because what I am saying in the room, of course, should be picked up by the microphone and transported back to the far end. So echo cancellation actually is a very complex part and needs to be done very carefully. There are a lot of components which go into that. It's what's called tail lengths, for example. If you are looking at what I just described about echo in the room, so if you have four glass walls around you and the speaker says one thing, that sound is going to live in this room for a lot of milliseconds, and so the microphone is going to pick it up a lot and over a long period of time. The longer the tail length has to be in that echo canceller. All of that requires a lot of processing power in your device to actually do that for that time period.
Let's move on to the word noise. And there's always noise in the background. In fact, many times people even don't know what's happening in the background. How does technology reduce the noise while supporting the conversations?
It's interesting. So you get into a room, you always know, is this room noisy or not? Is there something running? Is the air conditioner running? And you think of this like, oh, this is a bad room. Now, if you are a microphone in that room, it's exactly the same thing. So the microphone picks up everything every sound that is in the room, whether that is speech or whether that is noise. So noise reduction really means that how can I ensure that the air conditioner noise is not being sent over to the far end, right? Because if you are sitting at the far end and you just hear this sounds the whole time from an air conditioner or from a fan or whatever it is which is close to the microphone, that is not a good experience, and you actually don't hear what people are saying. So noise reduction really means like, let's get rid of the room noise so that is not being sent over. And again, there are two different times actually when that happens. When nobody is speaking, it's comparable easy. You just detect what is noise, you cut it out, and you just send over either complete silence or what is actually called comfort noise, just a very light sound so that the far end knows there's still a connection. It's not just so completely dead on the line. Then when I'm speaking, now it becomes actually a more complex part, because while I'm speaking, the noise is coming in at the same time. Now I have to reduce that noise without changing the behavior and the acoustics of my speech or the person speaking in the room. And that actually creates completely new problems or additional problems to actually reduce the noise in that scenario and make sure that more voice and audio that is supposed to go over is being sent, and the noise level is being reduced in that scenario.
Automatic gain control is an interesting type of technology. People move around a room, they get closer and further away from the microphones. How does automatic gain control deal with this issue?
That's it's actually one of from an experience perspective, again, one of the big things. It's like not even people moving around. It's somebody sitting close to the microphone, and then the next person sitting 4 or 5 feet or 2 meters away from the microphone. And physics simply means that the further I'm away, the less of audio signal is touching the microphone. So somebody who is sitting 5 feet away or 2 meters away would sound way less loud than somebody who is just a foot or half a meter away. So automatic gain control actually goes in and looks at the level that touches the microphone. So what is the current audio level which comes in, and actually tries to normalize that over time so that the person who is sitting close to the microphone might have actually to go down a little bit in their level because it was too loud which was coming in, while the person which is sitting 5 feet away actually needs to be gained a little bit so that they actually get up on the same level. It's a very interesting concept, because you also now have to think about what happens to somebody who is outside of the room, and you can still hear it, but or that person is 20 feet or 5 meters away. What do you do now? So actually gain control is very sensitive to actually saying, okay, I'm gaining audio up to a certain perspective, so I expect people not to be further away than, say, 6 feet or 1.5 meters from the microphone. And then if I find an audio level which is below that, I'm no longer gaining.
As we mentioned previously, people move around the room, they're in different positions. Mm-hmm. There's another problem. How does a conference technology track the speaker that you want to forward?
If you have different speakers speaking in the room and you have several microphones in the room, the question is, if I'm speaking right now, which microphone should be used, microphone 1 or microphone 2? Because my signal might be good on microphone 1, but not good on microphone 2. But as you said, now I'm moving in the room, and now I might be maybe closer to microphone 2 than I was to microphone 1. So the signal which goes into the microphones has to be collected and compared at all times. You don't just want to mix all of the microphones together, because that typically generates way too much noise in the room, because now you would collect everything. What you really want to do is focus on where is speech, which microphone is that speech the closest to right now. Let me use that input on that microphone and let me gain it, as we just discussed with the auto gain, to actually come up to the right level. And for the moment, if that's microphone 1, let me ignore the input on microphone 2, because I already have what he's saying from microphone 1 and I have it on the right level. And that is, again, something which is happening constantly with an immediate changeover from one microphone to another if you're moving closer to one or the other, or actually just if you're moving your head and you're sitting between two microphones and you move from left to right, the signal processor is reacting to that immediately and actually selecting the right microphone to get the best audio input and send that over to the far end.
The word on the next slide, reverberation, is quite a word. What is that, and how do you solve it?
So dereverberation just talks about the echo in the room. So if I'm saying something, the echo does live in the room. As I said earlier, when you have 4 glass walls, concrete ceiling, and hardwood floors, you're saying a word, and that word is still there in this room and traveling around almost a second after you say it. So the question is, again, if we have a microphone in the room, and I'm the one who's talking right now, and I would be in such a room, what I'm saying is not only captured once by the microphone, it's captured several times by the microphone. So the question now becomes, we discussed it earlier for echo cancellation. The speaker is sending something out, it's hitting the microphone several times, and the echo canceller is actually eliminating all of them. Now with dereverberation, I'm actually saying something, and now the DSP has to figure out that when I say it the first time, and maybe with a little bit echo, it's fine to send it over to the far end. But if this room is a bad room and I have a lot of echo and reverberation going on, the point is I need at some point to stop that in the microphone and no longer send it to the far end, because otherwise I will be sounding at the far end like I'm in the room I'm in, which would be like a box and just echo traveling back and forth. So it's actually an interesting problem to be resolved on the microphone side when capturing people in the room.
I've tuned my equalizers on my music system. I have a very professional system. How does automatic equalization work in a conferencing room?
It's actually more or less the same thing as what you did at home, just taking emphasis on conference settings. Depending on room behavior, depending on walls, as we discussed, depending on how echoey or not echoey is a room, what kind of, what's the distance between walls, because that actually says which of the frequencies are traveling more or traveling less. You actually end up with a very specific behavior in a room. And the behavior is also dependent on where do I place the speaker and where do I place the microphones. And if you really go ahead and you EQ a room, what you do is you actually make sure that whatever is coming out from the speaker, A, feels best in the room, so that actually the right frequencies are being enhanced in the output, and some frequencies, maybe the ones which are more echoey in the room and generate more reverberation, are being put down a little bit, so that you actually create an experience from the speaker which is best for the room. And you typically do the same for the microphone, because the same thing, when I'm speaking, maybe the low frequencies are living very well in this room, so I actually take the equalizer and take a little bit out of the low frequencies and enhance the higher frequencies a little bit.
The next page has a term I've not seen before: human voice activity detection. What is that? What does it mean? How does it work?
It's an interesting concept which we have put into a lot of our products. What it actually means is there's a difference between human speech, which is really what you want to transport and play back at the far end, and other sounds in the room. Of course, we talked about noises and whether that's a fan or an air conditioner, but there's also other noises which might happen and then disappear again, right? So somebody taking some paper and doing something with it. The question now becomes, can I differentiate between a human voice and any kind of other noise that happens in the room, and just go ahead and only provide the human voice to the far end and actually block all of the other noises? And it's a little bit more than just noise reduction, because noise reduction is more looking for a constant noise in the room. So human voice activity detection is more looking for, I grab something on this microphone. Is this really speech? Is this really a human talking right now? Or is it just some other noise which came in and doesn't look like human voice? And then really making, again, a real-time decision of, no, this is noise. I don't want to send it. I stay on this audio over here, which looks way more like human audio and somebody speaking.
We have our last of our 8 here: automatic audio tuning. All right. How does the technology deal with the acoustic environment inside the room and then optimize the settings that it's tuning to the room?
It's when we talked about the equalizer beforehand, right? So how does the equalizer actually knows what needs to be done? When you said you have an expensive audio equipment at your home, you did it based on your ears and you were moving sliders and all of this. In a conference room, nobody's going to do that. Reality is, however, as I explained before, it's beneficial to have equalizer. It's beneficial to actually tune the audio for the specific room and for the setup of where's the speaker and where's the microphones. Now, an automatic audio tuning actually goes ahead and says, okay, place me in the room, place the speaker, place the microphones wherever it is. And now, after pressing a button, it goes ahead and plays a sound, maybe white noise, maybe whatever orange noise, to actually go through different frequencies and create and measure what's being played by the speaker, and using the microphones to actually say what is happening here right now. And now we can automatically say, based on, okay, I hear the speaker and I hear that kind of echoing in the room, which tells me about here's what the reverberation is. So I can go ahead and actually start to adjust the echo canceller to that. I can start to adjust the EQ of the system to it, both for the microphone and for the speaker. And I can really adjust to all of the different things which the audio will be like once you start your conference call. So this way, actually, the system is already tuned to the right settings, and that's all being done automatically without somebody having to go in and changing sliders, and actually more likely doing something wrong because he likes the sliders in a different format, all up, all down, or whatever else. That doesn't happen here. The system does it automatically.
We've talked about 8 different technologies, 8 different methods for improving audio conferencing. Would you draw some conclusions for us?
So I think talking about these 8 different things, it's very clear that there are a lot of different variables, a lot of different things that actually impact the audio in the room during a conference call. And that there needs to be automatic ways of actually reacting in real time to changes to it, but also generally just to work around them and actually resolve them to allow for the best audio experience and conferencing experience. So the built-in technology, which we just discussed, if you can't just take one of them or pick 2 of them, any of that will not really provide you the best experience. Taking all of them together and having all 8 of them and they interact with each other, that really provides you the best technology, the best experience for your calls. And of course, that's all built in because, as we said, you can't react in milliseconds using sliders. So the DSP, which is in the product or which in larger installations is its own component in the installation, really is the brain of the implementation for your unified communication for your audio in the room.
Now, you have a product called the YVC1000 and YVC1000MS that epitomizes what you're talking about here. Would you introduce those products for us?
Yes, so the YVC1000 or YVC1000 MS for Microsoft is actually a product which does all of the things which we just discussed. It has, besides all of the feature sets which are hidden from you or which don't have a direct interaction with you, where you do the automatic echo cancellation and the noise reduction, it also provides the automatic room training, where you set all of the parameters, where you learn how the room works by just pressing one button and getting the system being set up for the room. The interesting thing about the YVC1000 is really it comes in one configuration which has a speaker and a microphone, but it's extendable. So now you actually can have 5 microphones in the room, and all of the things which I just described, right? So they are completely different whether I have 1 microphone or whether I have 5 microphones. And again, here comes the auto tuning, the automatic learning of the system as an advantage to actually say, okay, I have to work this way now because there's only 1 microphone connected, versus I have to work the other way now because 5 microphones are connected. And with the Microsoft certification, there's actually a close integration also with Skype for Business or Teams, which actually allows you to control that application through the unit and using the buttons on the unit.
Many in the audience don't think of Yamaha as providing these technologies. Would you provide some information about the audio and video conferencing solutions you offer?
What Yamaha simply does here in unified communication is taking all of this experience, taking all of this knowledge of best possible audio, and actually providing it in products which are specifically designed for conference rooms and for conference applications. So the whole idea here is actually using the world-class audio knowledge and actually bring it into the environment in corporations where it's very easy to be used. And with the product which is actually shown here, the CS700, we also bring video into the room, because we are seeing that most conferences these days do actually rely on both audio and video. And so with the same idea of having world-class video as well as world-class audio, that's what Yamaha is providing here.
I'd like to point out that you have a URL at the bottom of the screen where there's a ton of resources available from Yamaha. And I'd like to thank Holger for this Conferencing Done Right EDUcast, providing this tutorial information. Thank you, Holger.
Thank you.